Welcome to the lecture on Monte Carlo simulation of queuing problems. So, we have already seen that we use these random numbers to solve different kind of problems, and the different kind of problems may be either in queuing or in replacement, inventory control, reliability. So, we will see that how it can be used for solving a problem in the case of queuing. So, let us take an example of a queuing problem which is at the doctor's clinic. A doctor is there, a dentist is there, and it is Monte Carlo simulation will be carried out to see the average waiting time of the customers. So, basically the simulation will start at 8 a.m. in the morning, and the arrival of the customer is fixed. So, they are coming at the scheduled arrival time, although arrival time may also be the random, but let us see in this case we assume that the arrival is occurring at a scheduled time. So, at a scheduled arrival case is there, every 30 minutes one customer is coming. So, this is the case of queuing. Now, in that case, although they are coming after every 30 minutes, but they are coming for 5 different treatments to be carried out upon them. So, they have 5 different kinds of service. So, the services are like you have filling. So, the services which the doctor provide is filling, then you have the crown, and you have cleaning, extraction and checkup. So, since this is a scheduled arrival, it may be unscheduled arrival, random arrival, and that will be again depending upon, so if you have some probability distribution, then based on that we can have the arrival time also. But in this case they are coming. So, first customer is coming at 8, second is coming at 8:30, third is coming at 9, and then fourth is coming at 9:30, and so. Now, they are coming for these different services, and they are coming for these services which take certain time, and the time required for the service is different. So, time required for the service is, for filling it is 40 minutes, and then for crown it is 60 minutes, it is 15 minutes, that is cleaning, extraction is 45 minutes, and checkup is 15 minutes. So, this is in minutes. Now, it has been seen by previous record, it was seen that the customers who come for filling has a probability for respective service. So, this is a probability that they are coming for filling. For filling the service time is 40, that is fixed, but probability that they are coming for filling is 40%. So, it is 0.40. Similarly, probability for coming that they are coming for the crown placement, that is 15%. So, that is 0.15. Probability for cleaning they are coming is again 15%. Probability of extraction they are coming for, that is around 10%. Similarly, probability for checkup is they are coming, it is around 20%. So, let us, this data is there, and you are told that you find the average waiting time. So, now the thing is that we do not know for what purpose he is coming. So, he will be coming, and that guess will be done by referring to the random numbers which are generated, and here there are stream of random numbers. You have some random numbers which are assigned, and based on that we will do. But anyway, that random number in the program can be called from the respective subroutine. Now, if you look at this, So, to assign the random numbers, again we need the cumulative probability. So, the cumulative probability will be in this case the probability will be here 0.40, then it will be 0.55, then it will be 0.70, it will be 0.80, and then it will be 1. So, this is the cumulative probability. So, as we have done in the previous examples, we will have to assign the random numbers from 00 to 99 in that, and if we assign the random numbers which are to be assigned. So, that will be from 00 to 39. So, there are 40 random numbers including 00. So, there are 40 random numbers which are assigned, and if any random number comes in between them, then we will take the service of filling. Similarly, you have again you will go from 0.40 to 0.54. So, that not 0.54, it is 40 to 54. So, this is the number. So, it will be 40 to 54. Similarly, it will be 55 to 69, then 70 to 79 and 80 to 99. So, these are the random numbers which are assigned, so that you can go and predict that when the customer who is coming, he is coming for what kind of service, and in that case you can say that if he is coming for cleaning, that time will be taken as the 15 minutes of time. Now, what we see is that we can find that how these customers are coming. Now, for that the random numbers which are to be used are basically, so random numbers which are given to be used are basically 40, 82, 11, 34, 25, 66, 17 and 79. Suppose this is the random number which is to be used for knowing what kind of service will be required by to the patient by the doctor. So, what we will see, we will have the patient here, and then we will have his arrival, and then we will have the random number. Further, we will have category of service and service time. So, this table can be made now. If you make this table, the patient number you have 1, 2. So, 1, 2, 3, 4, 5, 6, 7 and 8. Now, this patient arrival is fixed. So, this patient is coming at 8, he is coming at 8:30, he will be coming at 9, he will be fourth one will come at 9:30, fifth one will come at 10, and then he will be coming as sixth one at 10:30, seventh at 11 and eighth at 11:30. Then the random number assigned are shown, so that can be taken from the program, and if it is given here we will take that random numbers 40, 82, 11, 34, 25, 66, 17 and 79. So, these are the random numbers which are being put in. Now, based on the random numbers we have to see what kind of service will be assigned to him. So, if it is 40, the 40 is coming here. So, he will be going for crown. Then 82, 82 is again in this range. So, he will go for checkup. Further, you will have the, so for crown you have the time of 60 minutes. He will be having a service requirement of 60 minutes of time. For checkup, he will have a requirement of service time as 15 minutes. Then you have then further 11 will be in the first. So, he will be go for filling. So, filling will take about 40 minutes. 34 again is in the filling. So, again he will be going for filling and it will take 40 minutes. 25 is further in filling. So, he will go for filling, he will take another 40 minutes. 66 is in this cleaning. In cleaning it will take 15 minutes. Then in 17 again he is coming for filling. So, for filling again he is taken the 40 minutes, and for last one, that is 79 is in this range. So, it will be extraction. So, extraction will take, again extraction is taking about 45 minutes. So, this way what we see that the patient is coming and he is taking that much of time. Now, we have to see that how we have to find that when the customer comes and when he leaves, so that we can find the final time when he leaves and average waiting time. So, for that again we will make the table. So, it will be patient, then you have arrival time of the patient, now service time required for the patient, and the service starts at what time, and then further the waiting time. So, you have 8, we will go for 1, 2, 3, 4, 5, 6, 7 and 8. Now, in that we know that arrival time is fixed. So, the first customer is coming at 8, he is going at, and second is coming at 8:30, he is coming at 9. Then one is at 9:30, 10, 10:30, 11 and 11:30. So, now service time requirement we have already calculated that what is the service time requirement as per the random number which has come into the stream. The random number, as we discussed, the random number can be anything. Anytime we calculate in the Excel the random number, it will be different, and the random numbers are the uniformly distributed random numbers. From there the sample is taken, but we can have the generation of random numbers as per certain particular distribution also. So, the service time is 60, 15, 40, 40. And then further 40, 15, 40, 45, 40, 15, 40 and 45. So, this time is already there for a particular job for which the patient is undergoing. So, this time is fixed. Now, the service starts at what time? So, first customer when he is coming, there is no queue. So, he will be just joining the queue. So, his service will start at 8. So, he has the waiting time of 0. Then the second customer's service will start at 8 plus 60 minutes. So, it will start at 9. So, for him the waiting time will be 30 minutes. The third customer, so now the customer has come to get the service at 9 and he needs to get time of 15 minutes for the service to complete. So, at 9:15 he will depart, and once he will depart, this person's patient third's service will start. So, he will be coming at 9:15. So, then accordingly this person, since he is coming at 9 and he will be joining the service at 9:15, he has to wait for 15 minutes. Then this person will take another 40 minutes. So, at 9:55 he will allow the next customer to go into the service. So, this person has come at 9:30 and joined the queue at 9:55. So, the waiting time is 25 minutes. Then he will take another 40 minutes. So, he will at 10:35 he will be joining the queue, and since he came at 10 and he joined the service at 10:35. So, 35 minutes is the waiting. Then further he will take another 40 minutes. So, 40 minutes will be 11:25 and not 11:25, it will be, it is 40 minutes. So, 25 minutes left plus 15. So, 11:15. So, 11:15 he will, this customer 6 will join the queue, and that way the waiting time will be 10:30 to 11:15. So, 45 minutes. Then he will take another 15 minutes. So, the next customer will join the queue at 11:30. So, he will be waiting for about 30 minutes, 11:30 minus 11, and then at this point he will be taking 40 minutes. So, next customer will join at 12:10, and this person has got to wait for 12:10 minus 11:30, 40 minutes. So, what we see that the different customers has to wait for different number of times. Now, if we take the total waiting time will be 45 plus 25, 70, 105, 150, 180 plus 20, 220 minutes. So, the average waiting time can be computed, and average waiting time can be computed as as 220 divided by 8. So, it will be 27.5 minutes. This is how, for when you are given the sequence of random numbers, you can calculate this average waiting time in this fashion. So, what we have seen in the last lecture, problem, that you had the random numbers which are specified, but many a times you will have to generate the random numbers as per certain distribution, and then you have to calculate the parameter values. So, suppose we are dealing with another question where it is said that the inter-arrival time and service time, they are distributed exponentially, distributed with some mean value. So, as we know that if you have the parameter lambda, the mean is 1 by lambda. So, they have the mean values 1 by 0.5 and 1 by 0.75 minute respectively. So, this is given, and you have basically to generate now the random numbers. So, from the random number streams, so using this distribution of exponential distribution, you have to generate the random number, and accordingly that random number you will have. So, from there you will find directly the inter-arrival time itself. So, as we know that in that case we had seen that you equate the cumulative distribution function to some uniform distributed random number value, and then from there we generate the this inter-arrival time or service time, and then finally we are doing the queuing simulation. So, what will happen in that case? You will have, so what we see in that case, we had seen that normally we have 1 minus e raised to the power minus lambda x. That is what it was. So, we were doing the inverse transformation. So, 1 minus random number and then minus of 1 by lambda, and then we do the ln of that particular value. So, what we calculated was that minus of 1 by lambda ln of 1 minus r, that is what it was. So, basically if you take this random number as one random number 1 minus r as that, then in that case we can have that like that minus 1 by lambda ln u1. So, ln ui we can write for any particular, and this one random number is known to us once it is taken from the uniformly distributed number. So, you can get the u1 u2 like that for. So, once you put these values as the different ones, you can generate that stream of random number which fits for this exponential distribution. So, you can have these values and you can generate them. So, let us see if you have those random numbers, like you take as, if you take them as suppose from the table or from the uniform distribution, if it comes like 20, 23, then 86, 9 and 92, 35, then 38, 1, like that it goes. Suppose it goes, the u1 goes like that. So, you will have to generate the inter-arrival time from there. So, you put in this formula, you know the lambda value for this is 0.5. So, 1 by lambda is there. So, once you do that, you will get the inter-arrival time. So, that is suppose xi. So, this if you put this value into that expression, you will get the value as 3.22. You may get it as 2.94. Further, you may get it as 0.30, 4.82, then 0.17, then 2.10, further 1.94, and it will go on like that 9.21 and so. So, this will go on. So, this way you can generate the inter-arrival time if you do not have that particular distribution. So, using this distribution function, you can generate this way the inter-arrival time. So, what happens, once you know the inter-arrival time, you can find the arrival time. So, as you see this customer comes at suppose 3:22 am. So, because the first one, so he will come at 3.22. The next will be from 3.22 to 2.94. So, it will be 6.16, then further 6.46, then you have similarly 11.28, 11.45, then you have 13 point, it is 55, then you have 15.49, like that, then you have 24.70. So, this way the time will be recorded. Now, again you have the next parameter, that is yi. So, that is your service time. So, for service time, so this was done using the value of that particular lambda 0.5. So, if you put 0.75, in that case the another value can be found, and u2. So, for that, for before calculating this yi, you have to have the u2 values. So, suppose u2 you again take from the stream, and that value is 21, 44, 27, 70, 73, 36, then 59, 42, like that it is going. Suppose, so again you are going to put it into that expression, and from there you will get suppose yi. So, that is service time for the customer. So, it will be 3 point, so this will be 2.08, 2.08, then we will get 1.09, further you will have 1.75, 0.48, 0.42, 1.36, then you have 0.70, 1.16, and so on. So, this way if you do not have that distribution which is given to you, like probability is not given to you, earlier you had the empirical probability given. Now, in this case you are not given, you are simply told to generate these times as per certain distribution function. So, that we have studied that using the inverse transform technique, you can generate these numbers directly, which are basically exponentially distributed. So, you are getting directly these values. Now, based upon that you can simulate the particular queuing. So, suppose this person comes at 3.22 and he will have a service of 2.08. So, when he will depart, so he is going, so he will be going 3.22 and 2.08, so it will be 5:30, 5:30. So, this way he will be going from here. So, but the next person is coming at 6:16. The person is going at 5:30, but this person is coming at 6:16, and he has the service of 109. So, he will be departing at 7:25. So, this person will go out of this queue at 7:25, and at 7:25 this person will be able to go into the queue. So, he has to wait from 6:46 to 7:25. So, then in that case you have the waiting time, but then from 7:25 onwards he has the service time of 175. So, for that he has to wait. So, 725 plus 175, it will be 9. Further, then from 9, now this customer is coming at 11:28. So, at 11:28 he will be coming, and service time is 48. So, it will be again, it will be going together, and he will be so further. In that case, you are going to do the calculation and it will tell you. So, this way you can continue the simulation and get the values of waiting time for the customers. The time can be maintained in respective units, and you can get the time of waiting for the respective customers finally, and you can find the performance measures. Now, this can be, I mean, we can take any kind of distribution function, and for that we can generate the random numbers and we can do the modeling using these random numbers. So, this is how this Monte Carlo simulation is carried out, and it can be done in other areas also. It is a powerful tool which is used wherever there is complete uncertainty and there is very much difficulty in modeling very complex system. In those cases, this Monte Carlo system is proved to be a very helpful technique, very effective technique. When you go in the long run, it will tell you the values which are very much accurate to the actual phenomena. Thank you very much.